Hello everybody. Thank you very much for the introduction, Lakshmi. So, as I was introduced, my name is Peter Polik. I'm from SONEL company. And today I'm going to talk about verification of the photovoltaic installations. Okay, so I'm sharing my screen right now. Okay, so let's start. So first, let's look at different standards. And the one defining the checking the verification of photovoltaic installations, this is the IEC 62446. Of course, the photovoltaic installations, they have also AC parts. So here we will look at the 60364. Or as well as for any other low voltage installations, we can also look at Indian standards 732 or National Electrical Code. Okay, so this is how the photovoltaic installations looks like. So first, as we follow the flow of the production of the energy, we have the DC part, from the photovoltaic panels all the way to inverter. Then we have the AC part, so from the inverter to the transformer, and then the energy will be introduced to the electrical grid. So as we look in the standard, the IEC 62446 says that first we need to check the AC part according to the IEC 60364. According to IS 732 and according to the NEC. And then we're gonna check the DC part, and the IEC 62446 defines here the measurements on the DC part. Okay, so these are the standards behind the measurements. Now, as we look at our devices, well, they need to comply with safety standard IEC 61010, and the 61557 defines the accuracy. Okay, so now let's look our tests at different types of tests that the standards are defining. I'm going to do it other way around, and first focus on the DC part, and later just go briefly through the AC part. So as well, our main point for today is to talk about the measurements for the DC and the AC installations. I will just talk about those briefly. Okay, so let's look at the IEC 62446. What does it define? Well, we need some documentation about the system, and there are things like information about the system, designer, and installer. Also, we need the system description with appropriate diagrams. We need technical specs of the different devices which are used in the construction of this installation. We need the operation and maintenance manual. And finally, once we do our verification, then we can attach the report on the acceptance and commissioning verification or on the periodic verification. So that's all the paperwork that we need to provide after once we want to commission a photovoltaic system. Okay, so let's just focus right now on the verification part. And here the standard says that first we need to perform the visual inspection. If it's positive, then we can go to testing. That's when we use when we use the meters to check electrical values. And finally, we need to do the reporting. And in the report, we have the results and conclusions from the visual inspection and from the testing. Okay, so let's start with the visual inspection. And here we need to check the installation with all appropriate sensors to ensure that all electrical equipment has been correctly selected and correctly installed. Okay, now once the visual inspection gives us the positive results, we can move on to electrical testing. On the other hand, if we have some negative results of the visual inspection, then we stop at this point, we just write the report, and well, in the report, in conclusions, we are gonna give some recommendations what needs to be fixed. Then after it is fixed, we perform the whole verification again. So again, visual inspection. Now if it's positive, we can move on to testing and then to the report. Okay, so now let's move on to testing. Here the standard says that we need stable conditions. And the optimal conditions, that means that solar intensity would be about, would be at least 400 watts per square meter. And in case of checking the current voltage curve, we're gonna need at least 700 watts per square meter. Okay, now the IEC 62446 defines, let's say, like 3 types of tests. Category 1, Category 2, and additional tests. In Category 1, we have tests like continuity of earthing and equipotential bondings, polarity test, combiner box test, open circuit voltage and short circuit current of the strings, functional test, and insulation resistance on the DC part. The Category 2 tests, or Category 1 tests, these are the obligatory tests, and Category 2 and additional tests are voluntary. So Category 2 tests, that will be the current voltage curve and thermographical tests. And finally, additional tests. So here we can check voltage to ground. We can check the blocking diode. We can check insulation resistance, but in the wet conditions. And finally, we can perform shade evaluation. Okay, so that was just a brief introduction of all of these tests that we need to make. Now let's discuss them in details. So let's start with the obligatory tests, the test of Category 1. So first we have the continuity test. Well, this one is actually pretty easy. We just need to check the equipotential bonding from one point to another point. Before that, let's remember to auto zero the meters to get rid of the resistance of the test leads and just check the resistance of the part of installation that we want to check. Okay, the next thing, this is actually not described in Category 1, but as we are talking about electrical systems in total or maybe thunder protection systems, there's also a good idea to check the earth resistance. Okay, then the next test described by Category 1, that's the polarity check. So we need to check if the connections are made correctly. Then we're gonna move on to the string combiner box test. And it works like this. So as standard, well, we need to check the voltage between negative and positive channel. And here, depending on the system, it should be, for example, 1000 volts or 1500 volts. And in case here the polarity is reversed, we're gonna see the negative 1000 volts or negative 1500 volts. Well, however, the standard says that the minus sign is a very small sign and it can be overlooked by the technicians who are testing. Especially if you do many tests, you can just miss the minus sign before the number. So the recommendation from the standard are, they go in this way. We need to check the voltage on the first string. And this is going to be our reference for later. Then insert all negative connectors. So the strings share a common negative bus bar. We do not insert any positive connectors. And then we measure the open circuit voltage on the first string, positive to negative, and this will be our reference value. Then we leave 1 lead on the positive pole of the first string, and we're going to connect the other test lead to all the other positive poles of the strings. Now, if everything is okay, then the meter should show 0 on the display. And in case the polarity is reversed, it's going to show twice the value of our system. So for example, for 1000 volt system, we're going to see 2000 volts. And for 1500 volt systems, we're going to see 3000 volts on the display of the meter. So this way, we can easily spot a reverse polarity, and we will not miss any sign. Okay, then the next test, that is going to be the open circuit voltage test. And here, the meters of electrical values are going to give us the value of the open circuit voltage, which currently is produced by our panels. However, how to compare those, how to say if the results are positive or negative? Well, we need to compare these values with the specs of the panels. So the specs given by manufacturers of the panels. And they give the value of open circuit voltage in the standard test conditions. So the STC. Now, how we can convert the open circuit voltage measured in the actual conditions to the standard test conditions. So that is 25 degrees Celsius and 1000 watts per square meter. Well, for that reason, we're going to need a second meter that is checking irradiance and temperature. And once we get data from the meter, so the temperature, the irradiance, and once we have the specs of the photovoltaic modules, then our meters will be able to calculate the measured value of open circuit voltage into measured value of open circuit voltage in standard test conditions. And then it's easy. We can just compare the measured value with the specs given by the manufacturer of the panels. And as per standard, the difference should be not more than 5%. So here, for example, on the screen of this meter, the delta is 3%, and all the results are in green, and there's a green check. So this meter actually evaluates the results for us. In case the delta would be higher than 5%, then we would see here red X, and all the results will be in red. Okay, so that was the open circuit voltage test. Now let's move to the short circuit current. So here we are just checking the current, which is flowing through the string of the panels. And again, similar like in case for the voltage, the meter can measure the current in the actual conditions when we perform the tests. And again, the specs of the manufacturer of the panels give the value of the current in standard test conditions. So again, 25 degrees Celsius and 1000 watts per square meter of the solar intensity. So again, we're going to need another meter to check the solar intensity, the irradiance, and the temperature of our panels. And then once it has those two values, it can calculate the measured short circuit current into the standard test conditions. And then we can compare the measured value with the specs of the manufacturer. And here the standard says that the delta, the difference, should not exceed 10%. So again, we can see what is the delta on the meter. And this way we can compare the results. If it's within 10%, then it's good. If it's above 10%, well, then the result is negative. Okay, now let's move to the next test, and that's the operational test of the photovoltaic string. And here we need to switch on our photovoltaic system. And in normal operation mode, we need to test the current from each string. The measured values should be compared with either the values from other strings or with some calculated expected values. And now we can move to functional tests. So again, we need to turn on our photovoltaic installations, and we need to perform the tests to make sure that the operation of the system is correct. So, for example, here we can check the efficiency of the system. We can select if it's a three-phase system or a single-phase system on the AC side. And we are going to connect to the DC side, the AC side, and check different values. So here is, as example, is a screen of the meter. We can see here what is the efficiency AC to DC. We can see what is the voltage on the DC side. We can also see here apparently it looks like somebody was not connected to the AC side, but we would be able to see the voltage, the frequency, currents, and once we swipe the screen further on, all the other important parameters. Okay, and finally we move to the last test here described by the category 1, which is the insulation resistance. Okay, so first of all, what is the test voltage that we need to use to perform such tests? Well, it depends on the operational voltage of our system. So if we have some small systems below 120 volts DC, then we're going to test them with 250 volts DC test voltage. And the requirement is that the value of resistance of the insulation should be lower than half mega ohm. Further on, for the systems between 120 and 500 volts DC of their operating voltage, we are going to test them with 500 volts DC test voltage. And the requirements is that the minimum value of resistance is 1 mega ohm. Now, some larger systems between 500 volts and 1000 volts DC, the operating voltage, we are going to test them with 1000 volts DC test voltage. And again, minimum value of resistance is 1 mega ohm. And for the larger systems above 1000 volts, we're going to need to test them with a test voltage of 1500 volts. And again, the requirement is that the minimum value of resistance of their insulation will be 1 mega ohm. Okay, now how to approach these tests? Well, normally we cannot measure resistance of objects which are under voltage. So we will not be able to check resistance between DC plus and DC minus, because as long as we have the sun, then the panels produce the energy, and there will be voltage between plus and minus. So how we approach this test? Well, we perform 2 tests here for each string between DC plus and ground channel, and between DC minus and the ground channel. So we need to perform 2 tests, read out the results, and if they are higher than, well, half mega ohm for the small systems and 1 mega ohm for the bigger systems, then the result of our test will be positive. Okay, so those were all the obligatory tests of category 1. Now let's move to the voluntary tests of category 2 of the IEC 62446. The first test that we can perform over here is the current voltage curve. So we connect the meter to the string. I'll press the start button, and we're gonna see the curve It looks like this. We also see the power curve here. And this gives us the following information. So we have the open circuit voltage, the short circuit current. We can also check what is the voltage and current value for the maximum power point. Here is the maximum power point on the power curve. Also, we can check this way the performance of the array. We can check the fill factor, and we can spot different defects or shading issues. Then the curve will look differently. Okay, just we need to remember that to check the current voltage curve, we need conditions for the light intensity above 700 watts per square meter. Another test, which is described by category 2, this is the thermographical test. And here the standard defines 4 types of those thermographical tests. The general one, module hotspots, bypass diodes, and cable connections. So for the general, the temperature difference between hotspot and normally operating array is most important. It should be noted that array temperature is a function of irradiance, wind speed, and ambient temperature, which vary significantly throughout the daylight hours. We need to document temperature extremes, investigate each thermal anomaly to determine its cause, and use visual inspection or electrical tests to investigate further. So if we find a hotspot, first we check visually what is the reason for that hotspot. And if we cannot determine this visually, then we're gonna use the electrical test to determine what's the problem. In some situation, we need to repeat the investigation after opening the circuit. And here we need to allow at least 15 minutes after opening the circuit for the temperature equilibration. The second types of the test, these are the module hotspots. Module temperature should be uniform with no areas of significant temperature differences. A hotspot usually indicates an electrical problem. Well, however, still, here we have a very nice picture which shows some electrical problems. Probably here the panels should be replaced. But we can also see sometimes some things which are just dirt. It could be some physical dirt, like, for example, well, bird droppings, maybe some leaves which are falling on the installation, some other dirt. So here we can easily notice this with a visual inspection with our eyes and very easily fix the problem just by cleaning the panels. Okay, the first type of tests of the thermographical test, this is checking bypass diodes. In any bypass diode if any bypass diodes are hot, we need to check the array to look for obvious reasons like shadowing, debris on the module protected by these diodes, and if there is no obvious cause, well, then we can suspect a bad module. And finally, cable connections. So the connections in wires between modules should be significantly hotter than the wire itself. Well, yes, they should not be significantly hotter. And if they are hotter, we need to check for different loose connections or corroded connections. All right, so these are all the thermographical tests, and that was all the category 2. And now let's move to the additional tests, which are also voluntary, same like the category 2. Okay, so here the standard defines the voltage to ground test, and this is for the systems that are using high impedance connection to the ground. Now, the test procedures here are provided by the manufacturer of the modules. So that's what the standard says. Just follow the procedures defined by the manufacturers, and well, follow their follow whatever those procedures say. The next test, these are the tests of the blocking diodes. So in the MC4 connectors, which are used in photovoltaic installation, there's the blocking diode inside. Blocking diodes can fail in both open and short circuit states. This test is important for installations where blocking diodes are fitted, and all diodes shall be inspected to ensure that they are correctly connected, so the polarity is correct, and that there is no evidence of overheating or carbonization. In normal operating mode, the voltage across the blocking diode shall be measured. The criteria for passing the test, so the voltage across blocking diode should be between half volt and 1.65 volts. Where the voltage is outside of this range, the system shall be further investigated to determine if the diode failure is an isolated incident or the result of another fault of the system. Okay, the next test of the additional tests, that's the that's the insulation resistance test in wet conditions. So generally we perform it same way like the regular tests of insulation resistance. However, we're gonna need to spray our test site with water to create some moisture, and then we're gonna perform our tests. And final test here defined by the standard in the additional tests. This is the shade evaluation. Now, let's imagine a situation like we have over here. We have some building. It has solar panels on the roof, but it has also some sort of construction here on the roof, which is giving us shade. And the panels, they work as efficiently as their weakest link. So the shaded panels over here. Now, of course, we can use different optimizers to increase the efficiency of our installation. However, it all depends on the amount of hours when the shade appears over here. And let's say if it appears only in the morning or in the evening for a short time, then this is not a problem. We can just install some optimizers. However, if this shade appears over here through most of the day, then it will be simply just more efficient not to build this line of panels over here and start a little bit further, and then the system would be more efficient. So that's the reason for the shade evaluation. Okay, so those were all the tests. Now let's look at the report and what should be included in the report. And that should be, well, first of all, we need all the documentation of the system that I was talking at the beginning. And in the report itself, we need the summary information describing the system, like the name of it, the address, the owner of the system, and so on. Then we gonna need a list of the circuits that have been inspected and tested. We need a record of the inspection. And now inspection, this is the visual part. So it's also a good idea to take some pictures once we are doing the tests. Right now, it's very easy. Most of our phones, they have cameras, so we can take pictures with our cameras. Well, especially remember about the pictures of any faulty parts. So in case we have some elements which are failing, take the pictures of them, put them in the report. Now, if the part of the visual inspection gives us the negative results, then we should just give some recommendations for fixing it. And if we have the positive results of the visual inspections, then in the report, well, of course, we move to electrical tests, and in the report, we should provide the records of the results for each circuit that we have tested. Well, finally, we need to recommend the interval until the next verification. Well, and here, well, typically it is 1 year, but it all depends also on different conditions under which the systems are operating. Still, we as the test technicians, we can recommend a shorter time interval for the next verification if we have some hard conditions, like, well, for example, if there are SONEL panels at the seaside, we can have stormy weathers, we can have salty water in the air, then the salt will deteriorate the systems, and then, well, I would recommend to verify our systems more often. Okay, and finally on the report, well, we should sign it. So the person who has performed all the verification, the visual inspection, the tests, and obviously has the right qualifications to perform such tests, then this person will sign the report. Okay, so this way we went through all of the tests of the DC part of the photovoltaic installations, the obligatory one of the category 1 of the IEC 62446, and the voluntary one of the category 2 and additional tests. Now let's look at the equipment with which we should perform the measurements. Well, and obviously we have different meters for the electrical values, but let's remember also about the meters to check the solar irradiance, the solar intensity, and the temperature. And here we have example of such meter. We put it on the side of the panel. Now let's remember to level it with the panel, because if the panel is this way, we cannot move it, the meter up or down, because then we would get the wrong reading of the irradiance value. So it has to be leveled with the panels. And then typically those meters will send the information about the solar intensity and about the temperature to the meters of electrical parameters. And thanks to this, the electrical values like open circuit voltage, short circuit current, they can be calculated into the STC conditions, the standard test conditions. Okay, so those meters are important. And now further on the meters for electrical values. Well, we need to make sure that the meter that we select can measure all the parameters as defined by the standard. There could be different meters for some smaller installations. We need to check what is the maximum operating voltage and current, or for some bigger installations, like for the power utilities that work with, that provide solar power plants, then they will work with higher voltages and currents. And also there can be multifunction meters, which have a function for photovoltaic installations. Well, here's an example of one. It can check the photovoltaic installations, as well as low voltage AC installations, electrical car chargers, power quality, and so on. So for example, if we have some company, some factory, which has solar panels on the roof, which has electrical car chargers in a parking lot, then we can just use 1 meter to check the entire building, the photovoltaic installations, the car chargers, and maybe even do some power quality studies. Okay, so those were the meters for electrical values. Now for thermographical inspection. Well, here, in case we just want to check the photovoltaic installations, well, we can use like mid-scale or lower mid-scale camera. I say like about minimum requirements, not to overkill our selection over here. So that's something, resolution here like 256 by 192 pixels should be enough. Also, well, we will not check burning metal, so the temperature range well, should be enough over here. Important things are to have the visual and infrared image, because, well, the camera will show the infrared image, and sometimes when we look with our eyes on the measured object and on the screen of the camera, it may be hard to recognize what we are actually looking at. Because the infrared image and the hotspots that is showing may differ from what we visually see. And if the camera has also the visual lenses here, then we can use different mixing modes and put the infrared image over the visual image, and this way it is easier to us to identify the problems that we have spotted. And also automatic focus may come in handy, because then well, we don't need if we have the camera with the fixed focal value, we're going to need to come closer or further from the object that we are checking. And if the camera has automatic focus, then we just press the button and it's going to focus on our object. Okay, so those were the thermographical tests. Now one more hint, because as I said, there is one part of the standard about the combiner box test. And when we need to check the polarity of all of the strings. And the standard define, we put all the negative connectors together, and we're going to check between positive of a first referral string and each other string. And then the meters should give us the value of 0 if the polarity is correct, or the value of twice the operating voltage of our system if the polarity is reversed. So, for example, in case of systems that have operating voltage of 1,500 volts, we need to get a multimeter that shows us 3,000 volts DC. And that is actually quite a high value for the multimeter. So there might be also an option of getting some sort of adapter which is going to calculate. And this is just a splitter over here. We can connect it to different multimeters or clamp multimeters. Well, this one actually has a holder which we can put in the clamp of the multimeter. And we can use it like this. So this way, we can get the values of even up to 3,000 volts. So that's just well, some useful adapters. Okay, so this way we have gone through all of the tests of the. So we went through what is the standard saying, how to perform these tests, and briefly about the equipment that we can use for performing these tests. And now, so as the energy flows between the inverter and the transformer that introduces the produced energy into the grid. Okay, so here, which standards are we going to follow? Well, the IEC 62446, the one about photovoltaic systems, it says to follow the IEC 60364-6. So basically the standard that defines the verification of low voltage systems. In India, this is also Indian standards IS 732 and the National Electrical Code. They define the test in low voltage installations. It could be the part of the DC or it could be any low voltage installation in the building. And here, similar, the verification, it includes the inspection, so the visual check, testing, so checking the electrical values with the meters, and finally the reporting, which where the report includes the results of the visual inspection and the electrical testing. So first we perform the visual inspection, and the same like on the DC part, we should inspect all electrical installation with appropriate sensors to ensure that electrical equipment has been correctly selected and installed. And then here, well, this is a quote from the standard where we have all the big checklists for the visual inspection. Well, there's a whole list of different points. We need to use the appropriate ones. Some, of course, may not apply to our installations, but you can find this big checklist in the standard. Once the visual inspection gives us the positive results, we can move on to electrical testing. And the tests for the low voltage AC installations, as per standard, are all of these tests. So in case of the photovoltaic installations, we will definitely check the continuity of conductors and equipotential bondings. We would check the insulation resistance. Well, probably there will not be any supply from low voltage sources, because the power supply comes from the grid or from the panels. Well, in case on a transformer station we have any mats on the floors, we're gonna need to check their resistance. We would need to check the polarity tests on the AC side, check the automatic disconnection of supply in case of failure, and any additional protection. Check the phase sequence in case we have the three-phase systems, perform functional tests, and the voltage drop test. So basically, all the tests that we perform on any low voltage AC installations, and to perform those tests, we can use any multifunction meters that have appropriate functions, or just several single function meters. Well, here, especially for some power utilities, the multifunction ones may not be powerful enough. Okay, so basically here I wanted to focus on the DC part of the installation, so I will not talk too much about the AC part. However, there's one issue that I would like to address. When we are checking the fault loop impedance, well, we need to check it to get the value of fault current. And if fault current is higher than the current triggering the breakers here within a certain time, then the results are positive. So that's why we need to do that. And we do this test on live installation. And in case of photovoltaic installations, it may happen that the transformers will work at the voltage here on the low voltage side, which is higher than the regular 230 volts. So that's why when selecting the meter, we need to check its operating voltage to be appropriate to our system. Also, another thing, as we are checking the impedance, so impedance, resistance and reactance of the transformer, and the resistance here of the cables, it may also happen that in the photovoltaic systems, the inverter will be kind of close to the transformer. So the value of the impedance or the resistance of the circuit is going to be quite small. Like, normal conditions, For example, when I'm checking the fault loop in a building on a certain floor, my transformer is below on the ground, so there's a lot of cables in the walls with a certain resistance, and that will give us a bigger value. Now, in case of photovoltaic installations, this part may be shorter, lower resistance. There will be less resistance in these cables, right? And that's why we need a really precise meter. So when selecting the meters for checking fault loop impedance here, make sure that they are working with the appropriate operating voltage. So whatever is the voltage on the low voltage side of your transformer, make sure that the meter can handle that. And another important parameter is to make sure that your meters can also measure low values. So here, also a good idea is that they would have the 4-lead test method, because with 4-lead test methods, we don't need to worry about resistance of the test leads of the meters. Okay, and another thing, as voltage is present there during our tests, it may be also a good idea if your meters they have a remote control. Like here, there's an example of 1 meter, and the guy is starting here the test and viewing results through some application on his tablet or smartphone. Okay, and finally, we need to prepare the reports. So we can have different software. Here's the one just for downloading data from the meter, and the other one is for creating the reports on any installation, photovoltaic, electrical car charging, and regular low voltage installations. So these are all the tests that we need to perform on the AC part. The AC comes first, unlike my presentation, then the DC part. And I've discussed here the types of the tests we need to perform, the methods how we need to perform, and gave you some brief information about selecting your tools which could work with these installations. Now, if you have any further information, you are free to contact us. That's where our main office is. That's his email, and this is his phone number. So you are always welcome to contact us in case you have any questions. Okay, and that's it. I would like to thank you very much for listening to my presentation. And if you have any questions, well, feel free to ask us.